and Assalamualaikum to everyone. Welcome to our video group presentation. We are from JCDCS 1434A. Today, we will be sharing with you one of the topic in Introduction to Mechanics, MAT272, which is the application of Newton's laws in our life.
Now, let me introduce our group member. First is Nurul Farhanis binti Zuraidi, metric number 2023-645594. Second is Riana Maisara binti Rosti, metric number 2023-460684. Lastly is Emilia Noedrin binti Muhammad Azam, metric number 2023-677286.
Assalamualaikum and hi. So now, I will explain the introduction about what is Newton's law. Newton's law of motion are three basic laws of classical mechanics that describe the relationship between the motion of an object and the forces that acting on it. This law can be paraphrased as follows. First is Newton's first law, Newton's second law, and lastly Newton's third law. The three laws of motion were first stated by Isaac Newton in his Philosophia Naturalis Principia Mathematica, which is in Mathematical Principles of Natural Philosophy, that originally published in 1687. Newton used them to investigate and explain the motion of many physical objects and systems, which laid the foundation for classical mechanics.
Next, we will continue with our explanation about Newton's law of motion. Newton's first law of motion, which is the law of inertia. An object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction, unless acted upon by an external force. If forces act on a stationary or static body and the body remains at rest, the acted forces must be balanced, means the resultant force in any direction must be zero. For example, the golf ball will remain on the ground until the golfer hits it. Newton's second law of motion, acceleration. The rate of change of momentum of an object is directly proportionally to the force applied, and this change occurs in the direction of the applied force. A force applied to an object at rest causes it to accelerate in the direction of the force. The formula that we use for second law is F equals to ma. Applied force equals to mass times acceleration. The law of acceleration. The car accelerates forward since the force due to its engine is greater than the friction on the road. Lastly, Newton's third law. Newton's third law states that when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. The third law is also known as the law of action and reaction. This law is important in analyzing problems of static equilibrium, where all forces are balanced, but it also applies to bodies in uniform or acceleration motion. The law of action and reaction. Every action force has a reaction force that is equal in size and opposite in direction. For example, on a rocket launch, the shuttle exerts a downward force, and the reaction force of the same size pushes it upward.
Next, why do we use Newton's law? First of all, we use Newton's law is to understand the relationship between the motion of an object and the forces acting on it. We also use it to helping us in accurately calculating the forces of motion connected to a certain action. Other than that, it used to increase our understanding in the application of Newton's law in real-life situation. Next, let's move on to the discussion. In this video, we provide you two examples of application Newton's law in real life. Problem statement 1. It's sunny weekend and Amir is heading to the lake. He used his jeep to tow a boat. Amir need to bring the jeep fast to reach the planned time. A jeep of mass 1,700 kg is pulling a boat of mass 900 kg. The driving force exerted by the jeep is 2,000 Newton, and there is no resistance to motion. The question is, find the acceleration of the jeep and boat, and find the forces in the tow bar between jeep and boat. This question can be solved by using three steps. First step, we need to draw and label the diagram based on the problem statement. Second step, we need to write the formula. F equal to ma and input the value to find the acceleration for the system. Step 3, we need to substitute the value of acceleration to find the force between jeep and boat. Here is the problem solving for question 1. First step, we need to draw and label the diagram. Like shown in this slide, from the diagram, we can see that applied force for this system is 2000 Newton and the mass of jeep is 1700 kg and the mass of boat is 900 kg and the acceleration is unknown. Second step, to find the acceleration, we can use formula F equal to ma, which is F is applied force equal to 2000 Newton and m is we need to add mass of jeep and mass of boat, and we got 1700 plus 900 a. And we simplify the equation. To find a, we need to divide 2000 divide 2600 and we got a equal to 0.77 meter per second square. By using a equal to 0.77 meter per second square, we can find the force between boat and jeep, which is the tension force. To find tension force, we can use formula F equal to ma, but for the F here is different because F need to minus it with T. Because applied force and tension force is the opposite direction. And for the mass, we just need jeep mass because the tension for boat and jeep are the same. And by using all the value, we substitute into the formula, which is F is 2000 minus T equal to 1700 A. And we substitute A value, which is 0.77, and we got 2000 minus T equal to 1309, and T we got 691 Newton.
Okay, so for problem statement 2, Ali brings his younger brother to the playground every afternoon. His brother enjoys playing on the slide. The slide is inclined at an angle of 30 degrees to the horizontal. If his brother's mass is 40 kg, calculate the acceleration of his brother down the slide and the normal force acting on him. So, how to solve this? Is draw and label the diagram. Then, we convert to free body diagram. Next, we will able to see all the details that state in the equation clearly. After that, we can find the acceleration and normal force by using F equals to ma and R equals to mg cos theta. Okay, now, let's solve the equation. To find the acceleration, we need to calculate x component, which is use F equals to ma. F is 40g sin 30 degree equals to 40a. G is 9.81, so got the answer for A equals to 4.907 meter per square. Second, calculate Y component to find normal force, which is R. R equals to mg cos theta equals to 40g cos 30 degree. G equals to 9.81. So the final answer is 339.8284 Newton.
Next, for the conclusion, Newton's three laws of motion can explain all aspects of an object's motion. The first law states that an object will remain at rest or in uniform motion unless acted upon by an external force, meaning that forces are required to change an object's motion. His second law describes how forces and acceleration are related to mass. His third law explains that forces act in pairs. For every action, there is an equal and opposite reaction. There is three Newton's law of motion that are: first one is the law of inertia, the second one is the law of acceleration, the third one is the law of action and reaction. Everyone should at least have a basis of knowledge of Newton's law to understand the motion that happen in real life.